Hello everyone. Today we're going to talk about transformations of graphs for international GCSE Excel students. Let's see what we will learn today. We're going to work on the transformations of trigonometric functions or the sine and cosine specifically in particular. So you're going to see here the function sine, how the graph looks like, or how the sketch of sine looks like, how the sketch and the graph of cosine looks like. For the sine, you're going to find here the graph. It has intercept and then maximum intercept, minimum, and then intercept. And the points are right here on the left. It's preferred you know them very well, or you can use the calculator, to find the points. Or it's very easy to be memorized if you know the angles 0, 90, 180, 270, 360, and then you calculate on the calculator what's the sine of 90, sine 0, sine 90, sine 180, and so on. But you must memorize that the function looks like here's the top and then a bottom like that. So you're gonna find the maximum point at 9 and 1, and the minimum point is at 270 and -1, and it's very easy to be memorized. For now, we're gonna keep it for you here for some time, and then we're gonna work on the exercise. If you go to the cosine starts from the maximum directly. It doesn't start from the minimum like from the intercept like sine. It starts from the maximum point. So it goes maximum intercept, minimum intercept, and then maximum. So it starts from 0 and 1, then here 90, 0, 180, -1, 270, 0, and then 361. These are the points as well. So you can memorize that these are main angles 0, 90, 180, and 270 here, 360. You can calculate on the calculator what's the cosine of 0, cosine of 90, cosine of 180, and so on. So you can memorize these points. So for now, you need to memorize what are the main the main sketch for the functions of sine and cosine. Because the questions, it will not be mentioned to you how the main curve looks like, and you're going to be asked to sketch you're going to be asked to either sketch the new function of the transformations, or it will be already drawn and you need to find what are the transformations that happen there. Here is another one, but the period now is wider. So here from wider from 0 till 540, and here 0, -19. Here we have from -90 till 540. This is the sine. How does it look like? Here the 0 intercept, maximum intercept, minimum intercept, and so on. Here's the cosine. How does it look like? Maximum intercept, and here the 0, 180, and -1, which is minimum, and so on. And here from 360, 0 to 364, here for the sine from 0 to 360, from -360 to 0, and the cosine as well from -360 to 0, 0 till 360. So let's move to what are the points you'll be asked to find. The first case, you may be asked to find whenever the function is y equals sine x added to something plus c, and here maybe it's y equal to a sine bx. Let's know what's a, what's b, what's c, and take care. Maybe they will be changed in the exam. It will not be, for example, b and c. It may be any other letters. For a is the middle line, or the line in the middle exactly of the curve, where, like, for example, if the curve is drawn like this here, so this is called the middle line. This is called the middle line, which is the value of a exactly. So for the standard one, for the standard functions, a is 1. Okay, so a represents, we can call it amplitude, but for now, let's just say it's a middle line. For b, as you know, everything is added or subtracted. For the x, this is horizontal shifting. It happens to the function. And the c, everything is added or subtracted out of the bracket of the function. This is vertical shifting. The vertical shifting, we need to know here that the curve has been shifted vertically upwards or vertically downwards, how many steps. And for the b, it has been shifted horizontally to the right or to the left. This is for A, B, and C. And here are the ways how to calculate them. A is half the average between, here, A is half the average between the highest value or the maximum value and the minimum value of the curve. And B is the shifting. For example, this point has been shifted to be here, and you need to know that in B it must be changed the sign to be written inside the bracket. C is have the maximum value added to the minimum value to need to know what are the translation or what's the translation happen to the function. In the second case, we're going to do examples to show you how you work out on these. Here in the second case, if you have amplitude or as we see the middle line, and this is called the periodic phase, or this is representing the stretch and compress of the function if the function has been stretched or compressed. How do you calculate this? A, as I said before, it's half the average between the maximum value and the minimum value. But for B, you need to do what? You're going to take 360, it's a rule, 360 divided by distance between two minimums, two maximums, or two minimums. For example, you took this maximum value, and there is, for example, here another maximum value. So what you will do is you're going to get the difference between the x coordinates. Here's the x coordinate, and here's the x coordinate. You need to get the difference between, or the distance between these two x coordinates. For example, it's 90 and here 180, so you're going to subtract 180 minus 90, it gives you 90, so you're going to do 360 divided by 90, it gives you the value. So let's work on examples to show you how you work out on these and how do you solve them. So but just you need now to memorize how to calculate A. It's half times the maximum value minus minimum value. C is half maximum value plus minimum value, and C is always the vertical translation. A is always the amplitude, and the horizontal shift, it has no specific rule, but you can figure it out from the main curve and the curve which is drawn in the question. B, it has the rule, which is 360 divided by the difference or the distance between the x coordinates of two maximums or two minimums. Let's see the questions. The first question here, you have the graph of y equals a sine x minus b added to c from negative 90 till 450. We need to figure out what's the value of a, what's the value of b, what's the value of c. You just need to pay attention in here. Let's check together. The first thing is a. We know very well how to get a. You need to check what's the highest value or the maximum value, which is 3, and what's the minimum value, which is negative 1. So if you're going to use the formula, which I have just written since a bit time, a is equal to half times the maximum value added to the minimum value, subtracted from, so we have 3 minus negative 1, it will be half multiplied by 4, so it's now 2. If you want to draw the middle line here, you're going to check how many units as a difference between both of these. Here you're going to find 1, here 1, 2, 3, 4, so you can draw a line in the middle here exactly. Okay, so you're going to find the difference is 2 steps in between. So here 2 steps, so the value of a is 2. Okay, so there are two ways. You can use the formula half times the maximum value minus the minimum value. It gives you the value of a. Or you can just draw the middle line in here for the curve. You're going to check the maximum value and minimum value. What's the distance between them? It's 4, so draw a middle line. So now we got the value of a. Then you need to go check the value of c. How do you get the value of c? Let's get the value of c. C is the translation. The translation. C can be calculated by half times the maximum added to the minimum to know the vertical translation that happened in here. Okay, so we need to check from the original curve. It was supposed to be on the x-axis and now has been shifted how many steps up there. Or you can just do it from the formula. It will be half times 3 plus negative 1, which is 2, so half 2 equals to 1. So the value of c now is 1. The remaining thing is, how do we get b? B, it depends on memorizing the main curve itself, because this will help you a lot in solving such questions. Let's memorize together. the maximum or minimum point, any distinguished point of the main curve. I'm gonna, for example, memorize what was the maximum point for the sine. For the original curve, it was the maximum point at 90 and 1. And now you have the maximum point is at 180 and 3, 180 and 3. Since b is related to the x or the horizontal translation, so you do care about the x coordinates, not the y coordinates. So the main curve is 90, and now it has been changed to 180. We need to know what's the value added or subtracted to change 90 to the 180, or the reason of changing 90 to 180. You're gonna find there is 90 added. So for the main curve, we need to know. So for the main curve, we need to know what's the value has been added from the 90 to make it 180. So we have added 90 in here, and this value, this 90 has been added. So since 90 has been added here, as you know, the translation that happened for the x, it must be changed, or the sign must be reversed to be written in there. So the 90, you already have minus inside the bracket. So this one is supposed to be written in the bracket x minus 90. So you already have negative in here. So you're going to just write 90. So the value of b is 90. Once again, the 90, what did happen to the 90 to become 180? And how did we know the 90 and 1? 90 and 1 from the main curve of sine before any changes. So it's 90 and 1. So 90 becomes 180. We have added here 90. So if you want to reverse the sign, it must be reversed and written inside the bracket as negative 90. You already have negative, so the value of b is 90. Now in the exam, you have done, for example, everything, and you're not sure that your answer is correct. How do you make sure that you got a right answer? What you need to do is, you're going to take, let's now erase some of these to have some space here. Okay. So let's now check if the answer is correct or not. I'm going to take 1 point from this curve, for example, 180 and 3. What you will do is, take the equation now after you got the values. Y is equal to 2 sine x minus 90 added to 1. So now go replace the x value in this equation, which is 180. And then if the answer is 3, it means everything you got here is correct. But if the answer is not 3 or something different, so you need to get back and check what mistake you have done in the question. Let's go on here. So y is equal to 2 multiplied by, so y is equal to 2 multiplied by sine 180 minus 90, and then plus 1. So what you will do is, first of all, you need to go using BidMath, check what's the value of what's inside the bracket. 180 minus 90 is 90. So what's the sine of 90? It will be y equals now 2 sine 90 added to 1. So sine 90 is 1. Sine 90 equals 1. So 2 by 1 add 1. So it will be 2 plus 1, which is 3. So what the values we have got, or all they are correct. So once again, after you got the values of A, B, and C, how you make sure in the exam you got correct answers, what you will do is take any point is existing on the curve, for example, 180 and 3, 9 and 1, 0 and negative 1, it's up to you. Just replace the x value in here and do calculation. If you got the y value correct, the same as what's written in the curve, so it means what you got is correct. But for example, if you have a mistake, so you need to go and recheck what you have done. In some questions, A is not always positive. At the amplitude or the middle line, the sign is not always positive. It's sometimes being negative. How do you figure out if it's positive or negative? It's related to the function itself and the main curve. So you can sketch the main curve and start comparing between them. And if you're not sure, as I told you, you can just replace the values you got of A, B, and C, and then replace the x coordinate after taking a specific point from the curve. If the y coordinate is the same as what you got from the curve. So it means your answer is correct. If not, bx for x is between 0 and 360. As I told you, we need to find the values in here. This is case number 2. Whenever you have the periodic or the period here, it shows p shows the period or the stretch and compress for the function itself. The value of a, as what we have learned, a is half times the maximum value, minus the minimum value. So the maximum value here is 2 and the minimum is negative 2, so it will be half multiplied by the maximum value, which is 2, minus the minimum, which is negative 2. So if you just do it, it will be half times 4, which is equal to 2. But there is something very important. As I told you in the previous question, a is not always positive. Sometimes it's going to be negative. So you need to check here. For this curve, it starts from 0. As we know, the sine, the original sine curve, when it starts from 0, it goes intercept, then we have maximum intercept, minimum, and so on. So here, this is the intercept for the original function, and then maximum, intercept, then minimum, then we have then intercept. This is for the sine curve, the original one. Here is how does it look like. This is the original, so it goes up, but for this one it goes down. So you mean you have what? A negative sign for a, it's not positive this time. So just replace here, just put add here negative to this one, and then we're going to make sure at the end if there is something is wrong, we're going to check it by ourselves once again. For for b, how to get b? As I mentioned before in the presentation, it's 360 divided by the distance between two maximums or two minimums. What I meant by two maximums or two minimums, I do mean the difference between the x coordinates of the maximums and minimums. You're going to take the maximum and minimum here, or between two maximums, we're going to take just the x coordinate and the x coordinate here. This one, the x coordinate is at 90 degrees, and the next one, the x coordinate is exactly here. Let's see here the distance between them. You have 30, 60, then 90, 120, 150, 180, and then 210. So each square represents 30 degrees. So this is 210. You have 210 here. So we need to get the difference between 90 and 100 and 210. So it will be 360 over the difference between 210 and 90 degrees. So it will be 360 divided by the difference between 210 and 90 degrees, which will be 120. So 360 divided by 120 gives you 3. So the value of b is 3. So we have here a horizontal stretch by 3. Let's make sure if our answer is correct or no. So the function now, y is equal to negative 2 sine 3x. Take any point on the curve. I'm going to take 90 and 2 from the curve, which is given here. And then I'm going to replace it in the equation. So y is equal to negative 2 by sine 3 times 90. So negative 2 times sine 270. So it's sine 270, not negative. So sine 270 is negative 1, so it will be negative 2 times negative 1, which gives you positive 2. So it's correct. Y coordinate is positive 2, and the x coordinate was 90. So it means the values we got for a and b is correct. So once again, how do we get a? A is half maximum value minus minimum value. So maximum value is 2, minimum value is negative 2. You just add them here, multiply by half, it gives 2. So the value of a is 2. And the negative sign, how do we get the negative sign? We just have drawn the main or the main curve of a sine, and then we compare that here. This one is being reflected, so we added the negative sign. After that, what we have done is we got the translation or the stretching by 360 over the difference between two maximums. So we took the maximum here, which looks at 90 on the x coordinate. The one which is looks at 210 minus 90 gives you 120. So 360 over 120 gives 3. After that, how do we make sure the answer is correct? We took a point on the curve, which is 90 and 2. We replaced 90 here, and then we calculated and we got 2. So it means our answer is correct. Let's move to one more example to make sure we understood. Here in this one, it says we have a times cosine x plus b. Here, what we will do is, let's get a. A is at the highest. Here it's half times a, which is, take care about this. This is 2 and this is 3, so this one is 2.5. 2.5. And here this one, negative 2 and negative 3, it's here. It's negative 2.5. So it will be half times 5, which is 2.5. 2.5. And for the other one, for the BB is just horizontal translation. Horizontal translation. So you need to compare between an original point on the original curve for the cosine and one of the new points here. Let's take this point, or we can just take this one. The minimum here is 240 and negative 2.5. Since this is related to the x, so I do care about only the x coordinate. And what was the original minimum point for the cosine? It was 180. So what did happen to the x coordinates? 180 becomes 240 degrees. So what did happen? We just added 60. Since we added 60, what we will do, we need to reverse the sign. So 60 will be written inside as negative 60. What about the negative sign? Do we have a negative sign for the 2.5? As we know, suppose the curve for the cosine starts from 0 and 1 and then goes down, but this one it has been shifted on the x coordinate, so it has been moved. So suppose the starting from here, and it has been stretched as well. So let's try by taking any point from the curve and replace it in the values of a and b and cosine now. If it's correct, we just keep it now like 2.5 and negative 60. If it's incorrect, we can just adjust what's going on here in the question. Y is equal to, now 2.5 cosine x minus 60. So I'm going to take the point here, this one. I'm going to take this point. I will take 240 and negative 2.5, the one which we have here. So I'm going to replace x by 240. It will be 2.5 cosine 240 minus 60. So 240 minus 60 gives you 180. So you have cosine 180 and here 2.5. So if you just calculate this on the calculator, you're going to find cosine 2.5 times cosine 180 gives you negative 2.5. So now when you have 240, the answer is negative 2.5, which is correct. So the values of a and b, they are correct. Let's move to the last question now and see how do we do this. Now we have a cosine, and here's a and b. We're going to work on the value of a. A is equal to half times maximum and minimum. So the maximum value is here at 5, and the minimum is at the negative 1. So you have 5 minus negative 1. So it will be half times, this is 6, half times 6, it gives you 3. So the value of a now, just keep it now at 3. Regarding the negative or positive, we're gonna see later on. For C, what you need to think about now is point C. Just keep the keep now the B for some time. C is half times the value of the maximum value is 50 added to the maximum value is 5 added to the minimum value, which is -1, so it gives you 4. So it will be half times 5 plus -1, which is 4. Half times 4, it gives you 2. So it's gonna be 2. Regarding B now, take for example the point 270 and 5, 270 and 5, which is a maximum point, 270 and 5. Let's see what was the maximum point for the original cosine. It was, for this one, it was 360 and 1. Now I'm going to check the difference between the x's because this is inside the bracket. It's related to the x coordinate. This is horizontal shifting. So it will be 270, it's 360 has been changed, 360 has been changed to the 360 has been changed to 270. Okay, so now what's gonna happen? We just subtracted 90. We have subtracted 90. So let's suppose this one, it goes the -90 here. This one, you have either option. You have two ways. You can do what? You can keep it as, since this is a negative here, you can keep it as -90, and then you work on this by replacing, taking any point and replace it here. So why did we keep it as -90? Because here, if you're gonna change the sign up there, it will be x plus 90, which will change the function itself. Here 3, and here you have plus 2. It's supposed to be 3 cosine x minus -90 here. So the value of b is -90. You have 3 cosine. Now you have x minus -90, which is plus 90, and then add it to 2. I'm gonna take any point. I'm gonna take 2 and 270 and 5 as well we took before, 270 and 5. So I'm gonna replace 270 now. If the answer is 5, it's correct. So y will be 3 times cosine 270 added to the 270 added to 90, and then you add 2. So you do the first cosine. This is cosine 360, which is 1. So 3 by 1, and then add 2 gives you 5. So this is the value of y, which is correct. So now the value of b is correct. So how did we keep this as -90? Let's suppose the change from 360 to 270, it has been decreased by 90 degrees. So this one has been decreased by 90 degrees. So 90 degrees here, if I'm gonna write it, since there is negative here, so I'm gonna keep the b as it is. The b was, the change was here -90, and then I found that here is a negative sign, so I kept the b as it is, because if b is written inside, it's gonna be make it positive, and there is no positive in here, so b will be kept as -90. For some other students, they can do what? They can keep 3 here, and then they're gonna mention that this one has been reflected because it goes intercept and then maximum. For the cosine, it goes intercept and then it goes maximum and then intercept. So some students, they're gonna mention here is -3, and here is 2 will be kept as it is. So here, regarding this point, you must take care about something. If this one has been reflected, so it means there is the shifting is positive shifting that happened in here. Okay, so some other students, they can take -3, 90, and 2, and then they can try it here. If it works, it will help them. Let's move to one more point. Now, if I'm asked to sketch, how do I sketch the curve? Which is very simple. What you need to do is, you're gonna take, here it's from 0 till 360, you need to take 5, you need to write the 5 main points for the function itself. This is sine function, so I need to write what were the 5 main angles. They are 0, 90, at 180, and then we have 270, 360 here. And if you don't memorize, you can just calculate them from the calculator. I'm writing now the original points. For the sine, it was 0 and 0, 90 and 1. Here 0 and then -1 and then 0. These are the points for sine. Now you are asked to sketch, or already it's a drawing here. You are asked to sketch this function. You have two types of transformations. The first one, you have stretch, vertical stretch. So you need to multiply each y-coordinate by 2. Multiply each y-coordinate by 2. And here, you're going to decrease 30 degrees from each x-coordinate. So let's see what will the change will happen here. What's the change that will happen here? It will be, for this one, you have 0, and then you need to decrease 30 from x and multiply by 2 in the y. So when you decrease 30 from 0, it will be -30. And when you multiply 0 by 2, it will be 0. You need to decrease 30 from this, the 90, so it will be here 90 minus 30, which is 60. Double the y, it will be 2. Here, 180 decrease 30, it will be 150. Double the 0, it will be 0. Decrease 30, it will be 240. Double this, it will be -2. Here, decrease 30, it will be 330. Double the 0, it will be 0. So now these are the new points that we're going to draw. We have no negative in this range, so we're going to start with the 60 and 2. Then we have 150 and 0. You need to know, and each square represents 30 degrees. Then you have 150 and 0. After that, we have 240 and -2, 240 and -2, 330 and 0, 330 and 0. Okay, so what you need to do is you have -30 and 0. You can just do something here in the exam. You can see that one square here represents 30 degrees. So you can just measure this with the ruler and extend this a little bit here. And then you can erase it later on to get the graph accurately. So 30 degrees, for example, the measure for this one is half a centi. So you need to extend half centi on the left. So you have the -30 degrees. So you can plot the point -30 and 0 and start sketching like this. So if you noticed, it goes till the 1 here, so it starts from the 1 exactly. So here you can go till the 1 as well, and then you can erase the extra part you have done. So you can, the drawing starts from 1 here, and you can erase this because you have no negative domain in here. The domain starts from 0 till 360. It doesn't start from the -30. So this is how the new curve looks like. One more time, how did we do this one? We have already the original of sine, the original curve of sine is drawn. So you need to memorize what are the main points: 0, 0, 91, 180 and 0, 270 and -1, 360 and 0. Then you start applying the transformations. Transformation, we have 30 is added to each x, which means we will subtract 30 because we need to change the sign. This 2 represents 2 multiplied by the each y coordinate, which is a stretch. So you're going to double each y coordinate, and you're going to decrease 30 here from each x. So at the end, you're going to have these points. Try to sketch them. And as I told you, if there's something out of the domain, you can just extend it. Here, measure this exactly, and then extend it a little bit, and then sketch it. Later on, you can erase the extra part here. Now we're done from this video.